Hi, this is the last day of chapter 3. Today we're just going to look at correlation and regression wisdom. All right, so if we, and some of the stuff today we've talked about already in the chapter, I'm just bringing it up again because it's something we need to stress. Correlation and regression describe only linear relationships. So if I have something that looks more like this looks like it could be more exponential or quadratic. So correlation regression would not be a good way to describe this. We'll learn next chapter how we deal with nonlinear relationships. Extrapolation often causes unreliable predictions. So if I have some data, let's say between 60 and 100, um, maybe you have a real nice graph here. Now, it's interpolation if you're trying to figure out a value between 60 and 100. But when you're trying to estimate some predicted value outside of, to the right of 100 or to the left of 60, that's what we call extrapolation. And this data isn't good at predicting anything outside of the range that it shows. So, and sometimes you could get a reliable prediction depending on what the thing is, but you really have to question the result if it's too far outside of the data. Now, correlation is not resistant. Um, so if I had a nice scatter plot, this looks like a fairly strong correlation. If I had a point here, that will make the correlation closer to zero because that one outlier is saying that it's saying that this line might not be perfect for all values. So so it really can change the R value. And that brings up a good point about outliers and influential observations. Now, an outlier is an observation that lies outside of the overall pattern. So say if I have this, and if I have a point out here, that's an outlier. I could also bring that point down here, and it's an outlier. Anything outside of the norm, we consider that an outlier. Now, it's not going to be a very influential point if it's right here because it's right in the line of best fit. However, as I move this point, the line of best fit will also change. So if this point changes the line of best fit or other values, then that will not only be an outlier, but it'll also be an influential point. Now, this is a common question asked if an outlier is an influential point. And what you have to do is see if taking that point out of the data set will create a much different linear regression line. A lurking variable. A lurking variable is a variable that is not among the explanatory, which is generally the x values, or the response variables, which is the y variables in a study, but yet may influence the interpretation of relationships among those variables. Now, we'll learn a lot more about lurking variables, but there is a really strong correlation between heat, or I just ruined it, ice cream sales and murders. So as ice cream sales increase, so do murders, and it, they've shown this many times. But there's a lurking variable in here. You can't reasonably look at a graph that would show this and show that ice cream sales causes people to murder people. Um, however, there's a lurking variable of heat. And as heat increases, it's summertime, and there's many variables actually involved in this, but that can lead to murders increasing. But ice cream sales, I'm fairly confident, isn't the thing that puts people over the edge. Which goes along with saying association does not imply causation. Just because there's some association between murders and ice cream sales doesn't mean that ice cream sales causes murders. All right, correlations based on averages are not a good measure when applied to individuals. So if we're taking averages of some value, so like average height of, um, say, 4 people or something. If we're taking an average height of some group and then plotting it, average height of another group and plotting it, and so on, you can't do a good correlation with that. The both of the x and the y's can't use averages. They just have to use the actual height of people. All right, now here is something good to do whenever you see a set of bivariate data, so 2 variable data. The first thing you want to do is plot your data in a scatter plot. Then you want to interpret it for what you see. Remember, direction, form, strength, and outliers. So positive or negative, is it linear, is it quadratic, exponential, is it really strong, is it weak, and then you want to talk about if there's any outliers. Then you want to look at some numerical summaries, maybe the means, mean of x, mean of y, standard deviations of either of them, or r. And then you want to try to make some sort of mathematical model, whether it's a regression line or what it is. And then you want to look at how well that model fits by looking at the residuals and r squared. All right. Now hopefully you can get through your homework. Good luck.